Welcome to another fascinating journey through Earth's geological history. Today, we delve into the story of Vaalbara, the first known supercontinent that formed approximately 3.6 billion years ago. Let's explore how it came to be, what it looked like, and its legacy on our planet. To understand Vaalbara, we need to go back to the very beginnings of our planet. Earth formed about 4.54 billion years ago from the solar nebula. In its early days, it was a hostile environment, with frequent volcanic activity and a molten surface. As the Earth began to cool, its surface solidified, forming a crust. This process set the stage for the creation of continents. Around 3.6 billion years ago, the first supercontinent, Vaalbara, emerged from the amalgamation of the planet's early continental crusts. Vaalbara's formation was driven by tectonic activity. The Earth's mantle, in a constant state of convection, caused the movement of tectonic plates. These plates collided and fused together, forming the supercontinent Vaalbara. But what was Vaalbara like? Vaalbara was a very different place compared to modern Earth. The atmosphere was rich in gases like methane and ammonia, which created a greenhouse effect, trapping heat. This provided a relatively warm environment, despite the sun's weaker output at the time. Life on Vaalbara was primitive. The first known life forms were simple, single-celled organisms like stromatolites. These microbial mats thrived in shallow waters, slowly releasing oxygen through photosynthesis and gradually transforming the atmosphere. Our understanding of Vaalbara comes from studying ancient rocks. The oldest known rocks, such as those found in the Kaapvaal craton in South Africa and the Pilbara craton in Australia, date back to around 3.6 billion years and provide evidence of this primordial supercontinent. Vaalbara's existence was not permanent. Over hundreds of millions of years, tectonic forces continued to act upon it, leading to its gradual breakup. The fragments of Vaalbara drifted apart, giving rise to new landmasses and, eventually, new supercontinents. After Vaalbara, other supercontinents like Rodinia and Pangaea formed. Rodinia came together around 1.3 billion years ago, followed by Pangaea, which existed from about 335 to 175 million years ago. These supercontinents played crucial roles in shaping Earth's geological and biological evolution. Today, the legacy of Vaalbara lives on. The cratons that once formed part of this ancient supercontinent now serve as the stable cores of our modern continents. These ancient rocks hold valuable clues about Earth's early history and the processes that have shaped it over billions of years. Vaalbara's story is a testament to the dynamic and ever-changing nature of our planet. Understanding these ancient geological processes helps us appreciate the complexity and resilience of Earth's environment. Thank you for joining us on this journey through time. Subscribe to our channel for more in-depth explorations of Earth's fascinating geological history.